This is an example of word problems that use the vertex to solve. So let's go ahead and read the first one. A ball is thrown vertically upward. After t seconds, its height in feet is given by this function. After how long will it reach its maximum height? So it does help here to visualize what we're looking for. So if we just sketch out a little graph, so this is t and this is our height h, we can see by the equation of the parabola that the parabola is going to open down. In fact, you probably need to rewrite it in standard form, negative 16t squared plus 88t. Now that you can clearly see it opens down, so something like this. And then we can label what's going on this graph. So this is the time that it takes to reach the maximum height, and this is the actual maximum height. We need, it says how long will it take to reach its maximum height? So we just need the time. We don't need the second component of this. So time to maximum height. Now this is the x-coordinate of the vertex of the parabola. That means it has a formula, minus b over 2a. So b is 88, so minus 88 divided by 2 times negative 16. If you put it into a calculator, you'll get 2.75 seconds. That's how long will it take to reach the maximum height. Now, a different type of question. A company manufactures cars. The unit cost depends on the number of cars that are made. If X cars are made, then the unit cost is given by this function. How many cars can be made to minimize the unit cost? And then the second question, what is the minimum unit cost? So once again, it does help to visualize this question. So let's go ahead and do so. So this is the x-axis. This is how many cars are made, and this is the cost to make them. Looking at the quadratic function, I can see that it opens up this time, so something like this. Now, breaking it down into parts, this is the vertex. The x-coordinate of the vertex is how many cars we need to make to minimize the cost. And then the y-coordinate of that same vertex, that is your minimum cost, assuming that you make the minimum number of cars necessary. So let's go ahead and actually calculate this. So we do have to start with the x-coordinate. We can't find the y-coordinate until we find the x-coordinate. So the x-coordinate of the vertex, that is that formula minus b over 2a. So minus a negative 224 divided by 2 times 0.4. And that will be 280 cars. This answers the first question. How many cars must be made to minimize the unit cost? So that is the answer to that question. Now the second question, what is the minimum unit cost? So the minimum cost, well, that is the y-coordinate of the vertex, and that is accomplished or calculated by plugging in 280 cars back into the x values of the original equation. So that's 0.4 times 280 squared minus 224 times 280 plus 38,321. So the minimum cost is 6,961. And that is the answer to the second question. Another ball question. A ball is thrown vertically upward after t seconds. Its height is given by this function. What is the maximum height the ball will reach? So it's very similar to the first question that we did, but this time we're not looking for the time, we're actually looking for the maximum height. So we actually need to find the y-coordinate of the vertex. This is the vertex of the parabola. This is the maximum height. And this is time to reach maximum height. All right, now we cannot find maximum height until we find time to maximum height. So let's start with time. T equals minus b over 2a. This function is not in standard form, so look at it closely. B is 52 and A is negative 16. So minus 52 divided by 2 times negative 16. That is 1.625 seconds. Now, do not box it in. This is an intermediate result. We are not stopping here, we're actually continuing. Please don't truncate any of the numbers either. This will lead to the calculator errors or calculation errors. So now maximum height, that is the y-coordinate of the vertex. So we have to plug in this result into the t in the original equation. So 52 times 1.625 minus 16 times 1.625 squared, and that is 42.25 feet. Now that answers the question.